Let's see the using 4 bits what does they represent quickly, and then I'll show you what is the range. So I'm just dividing them into 4 rows each, so that it will be easy for me to say what the corresponding representation is. So in unsigned representation, this is unsigned. In unsigned representation, we know that they are straightforward. They are just the binary conversion to decimal. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is unsigned. And coming to signed magnitude representation, all the positive numbers are same, right? See, with 2 power 4 16 representations or 16 combinations, half of them will be positive and half of them will be negative, isn't it? Therefore, these first 8 are always positive because they are having 0 in the most significant bit. Therefore, in signed magnitude representation also, in fact, in all the representations, these positive numbers, they don't change. Only the negative numbers, they change. Now, what about this one? Again, the same thing. This is minus 0. You should not write it technically, but then that is what the concept is here. Minus 4, minus 5, minus 6, minus 7, right? And now, for ones complement representation, so positive numbers are same, 0, 1, 2, 3, 4, 5, 6, 7, this is same. Coming to negative numbers, there will be a difference, right? So we know that all zeros is minus, all ones is minus 0 and all zeros is 0. And 1, 1, 1, 0 is the ones complement of 1, therefore minus 1. And this one is the ones complement of 2, therefore minus 2. This one is the ones complement of 3, minus 3. Minus 4, minus 5, minus 6, and this is minus 7, right? This is about ones complement. And coming to twos complement representation, 0, 1, 2, 3, 4, 5, 6, 7, this is the positive numbers. And now going to the negative number side, so we know that this one, this weight of the first bit is minus 2 power 3 here, 2 power 0, 2 power 1, 2 power 2, minus 2 power 3, which is nothing but minus 8 here. And now this one is minus 8 plus 1, which means minus 7. This one is minus 8 plus 2, minus 6. Similarly, minus 5, minus 4, minus 3, minus 2, minus 1. Now, what is the advantage of this 2's complement? Nowhere else in signed magnitude and ones complement we are not able to represent minus 8, but then minus 8 is being represented only in 2's complement. Therefore, the number of numbers that can be represented using 2's complement, the range is actually more. Now let's see the range, which means given some number of bits, what is the numbers that can be represented in each one of them, signed magnitude, ones complement and two's complement. So I want to talk about these three. What is the number of numbers that can be represented in? One is signed magnitude, other is ones complement, and the other one is two's complement. So what are these? Now we have seen already 3 bits. With 3 bits, how many total numbers were possible? 2 power 3 combinations were possible, which means 8 combinations were possible. In that, half of them were given to positive numbers and half of them were given to negative numbers. And both the positive numbers and negative numbers in case of signed magnitude are starting from 0. Therefore, with 0 we can go to only 0, 1, 2, 3. Therefore, here I can go to 0 to 3 positive, and in even the negative side also we can go to 0 to minus 3 only, right? 0 to minus 3 in negative side. Therefore, what is the total range we can say here? It is minus 3 to plus 3. Got it? Now the same thing applies even for ones complement also. See, the main difference between ones complement and signed magnitude is the way in which you assign these combinations to the numbers is different, but then the total numbers are same. See, here we start from minus 0 to 7 and here we start from 7 to 0. Isn't it? Minus 7 to 0. Just the order is different, but the numbers are same. Therefore the range is same even in the ones complement also. So if it is for 3 bits, then the range will be from 0 3 to plus 3, right? And what about 2's complement? In 2's complement it is bit different. See this. Now with 3 bits, the total number of combinations possible is 2 power 3, which is 8, which means 2 power 3 8 combinations are possible, out of which half of them are going to be given to positive and then half of them are going to be given to negative. Now the positive side is going to start from 0, therefore 0 1 2 3 are possible on the positive side, but then in the negative side we don't need to assign one combination to 0. So if we have 4 combinations, you can directly give them to 4 numbers, 4 negative numbers, which means minus 1, minus 2, minus 3, minus 4. Therefore here the range is different, minus 4 to plus 3. This is the range using 3 bits in case of 2's complement number system, right? Similarly, let's see the range in case of 4 bits. Just now we have seen here, right? In case of 4 bits, again 2 power 4, which is 16, it is divided into 2 parts, which means 8 and 8. 1 8 is given to positive side and 1 8 is given to negative side. In both sign magnitude and 1's complement, both the positive side and negative side is going to take up one combination for 0. Therefore in positive side we can go from 0 to 7, and in negative side also we can go from 0 to minus 7, right? Therefore the total range is going to be from minus 7 to plus 7. And what about 1's complement? Same, minus 7 to plus 7. And what about 2's complement? See this. In positive side we have to assign one combination to 0, therefore 0 to 7. In the negative side we need not assign one combination to 0, therefore all the 8 combinations are available for negative numbers. So minus 1 to minus 8 you can go, or minus 8 to minus 1, right? Therefore here we can represent minus 8 to plus 7. You can check it. If you have any doubt, you can check it. See this. Here you can check here. So here we are going from minus 8 to plus 7, right? So minus 8 to plus 7, we have all the numbers there. Now in general, the questions asked will be like this. What are the questions that can be asked is, they'll say that we have n bits to represent either 1's complement, 2's complement or sign magnitude. Then what is the range that can be represented? Now in general, I am talking about n bits. In n bits, what is the range that can be represented in sign magnitude? See, with n bits, how many combinations can be formed? 2 power n combinations can be formed. Now, these 2 power n combinations can be divided into 2 parts. One is 2 power n minus 1, 2 power n minus 1. So, which means I am dividing this set of combinations into 2 sets. One set will contain all the numbers which are starting with 0, and other set will contain all the numbers which are starting with 1. And this set will be given away to positive numbers and this set will be given away to negative numbers. But then in the positive number side, we are going to start with 0. Therefore the maximum positive number that can be represented is going to be 2 power n minus 1 minus 1, right? Similarly on the negative side also, we are going to give away one combination to 0. In case of sign magnitude, what is that combination given away to 0? That is minus 0. That is 1 followed by all zeros, right? And what about this one? 0 followed by all zeros. Therefore 0 followed by all zeros is 0, as well as 1 followed by all zeros is also 0. Now from 0 to, what is the smallest number that we can represent is minus 2 power n minus 1 minus 1. Got it? Okay. Now you can substitute this in place of 3. You can substitute and check it. In place of 3, if you can substitute 3, then it is 2 power 3 minus 1, which is 2 minus 1, which means 3. So 0 to 3 is possible. Therefore 0 to 3. And in the negative place also 0 to minus 3. That is by minus 3 to plus 3. Got it? Now, therefore what can we say about the range? The range is going to be minus 2 power n minus 1 minus 1 to 2 power n minus 1 minus 1. So this is the range which is possible with sign magnitude representation using n bits. Now we can say that using the same logic, we can even say that the same logic is applicable for 1's complement number system. Only difference is in 1's complement number system, positive 0 is represented with all zeros and negative 0 is represented with all ones. Okay, remember that. And next thing is, now with the same n bits, let's see what happens in case of 2's complement number system. In 2's complement number system, see, we are going to have 2 power n minus 1 positive numbers and then 2 power n minus 1 negative numbers, right? 2 power n minus 1 negative numbers. Now using these many combinations, these many positive combinations, how many numbers can we represent is, since on the positive side we have to dedicate one combination to 0, one of them is given to 0, therefore maximum positive number we can represent is going to be 2 power n minus 1 minus 1. This is the maximum positive number we can represent. Now on the negative side, we need not dedicate any combination to 0, therefore when we have these many combinations, all of them can be dedicated to one negative number starting from minus 1. Therefore if you start from minus 1, I can go till the smallest number, which is nothing but minus 2 power n minus 1. Very important. From minus 1 we can go till minus 2 power n minus 1. Therefore what is the range we can say? On the negative side we are going till one number lesser than the earlier one, right? Which means on the negative side we can go from minus 2 power n minus 1 to, on the positive side we are going till 2 power n minus 1 minus 1. Therefore this is the total range of numbers that can be represented in 2's complement number system. Now the questions on this will be, they'll ask you some questions like this. So you should be able to understand whether a given number can be represented with these many bits or not. So some questions will be like this. We want to represent 15 in 2's complement number system. Then what is the number of bits required, right? So now we know that, let us say the number of bits required is n. Then what is the maximum number that we can represent using 2's complement? 2 power n minus 1 minus 1. This is the maximum positive number we can represent using n bits. Then in that case we are supposed to find out what is the value of n. So which means this particular number has to be greater than or equal to this. Then what can we say? 2 power n minus 1 has to be greater than or equal to 16. Then what does it mean? Apply log on both sides. N minus 1 has to be greater than or equal to 4. Then what does it mean? N has to be greater than or equal to 5. What does it mean? 4 bits are not enough. In order to represent 15, we have to go with 5 or more, isn't it? That is right. Even if you check it, with 4 bits we cannot represent 15, right? So similarly they will ask you some question like this. Given the number of bits used are 8, then what is the range representable, or what is the range of numbers that can be represented in 2's complement? Then in this formula you substitute 8. Then what do you get? Minus 2 power 8 minus 1, which is nothing but minus 128 to 127, right? I'll just take one more example. Just observe this. I hope that you are getting these examples. One thing is they will say the number of bits and then they will ask you what is the range. Other thing is they will give you some number and they will ask you what is the number of bits needed in order to represent this number, right? Now they will say that minus 16 is represented using 4 bits in 2's complement. What will happen? That is what they will ask. Now just see if minus 16 can be represented using 4 bits in 2's complement. Now in 2's complement, what is the range that we can represent? Minus 2 power n minus 1 to 2 power n minus 1 minus 1. In place of n, if you put 4 bits, this is 4 bits. If you put 4, then what do we get is minus 8 to plus 7. Therefore this is the range we can represent in 2's complement, right? But then we are supposed to represent this number. We are supposed to represent minus 16, but then we can represent only minus 8 to plus 7. Therefore if you try to represent this one in 4 bits, then this condition is called as overflow, which means you will not be able to represent it there. See, sometimes when you are doing this arithmetic means addition, subtraction, multiplication or division, when you are doing it on pen and paper, using pen and paper, there is no problem called overflow because you have enough space to write the result. Sometimes what happens is when you try to add two numbers, then the result produced might be so big that you may not be able to accommodate in the given bits. Then that condition is called as overflow. I'll just give you an example. See this? Now using 4 bits, we can represent -8, isn't it? Therefore, if you add two -8s, which means if you add -8 plus -8, the result will be -16, but when you try to represent in 4 bits, you will not be able to write there, and therefore this condition is called as overflow. Why should we be caring about overflow in computers when we are not caring about it in our using our pen and paper method? Is in pen and paper you have space there, but when you are doing it in computers, you have to store the result inside a register. Therefore, the result should not cross the size of the register. For example, if you having 8-bit registers, the maximum range we can represent using 2-bit, this 2's complement number system is -128 to 127. If the result is exceeding this number, then there will be an overflow, right? Therefore, we have to even catch those overflow conditions. I'll tell you how to catch it. For now, just focus on this. Next, we shall see the arithmetic, 2's complement arithmetic. Just focus on some few examples, okay? Let's say the question is how many bits are required to represent -16, or let us say -30. This is the number which we wanted to represent. Now how many bits are required to represent -30 in 2's complement? Okay. Now why am I talking only about 2's complement? Is it is widely used number representation in computers. It has been widely used, and now most of the questions that will be asked on in GATE or any other exam will be on 2's complement only. Now -30 and this one. So what you should know is it is a negative number. Negative number means you should go on to the negative side. Now using n bits, so let us assume that n bits are required to represent -30 in 2's complement, right? Using n bits, what is the smallest negative number that can be represented, or what is the smallest number that can be represented is -2 power n minus 1. Now -2 power n minus 1 is the smallest number that can be represented using n bits. Therefore, this number -2 power n minus 1 has to be less than or equal to 30, right? Then what does it mean? Multiply both these sides with minus. Then what do we get? 2 power n minus 1 has to be greater than or equal to 30. Now what does it mean? That means that apply log on both sides. N minus 1 has to be greater than or equal to, if you apply log to this, I think you are going to get 4 point something. Let's say 4.5 or something. Okay. What does it mean? This n minus 1 has to be greater than or equal to 4.5. What does it mean? N has to be greater than or equal to 5.5. Therefore, it means that in order to represent this, we cannot use 5 bits. We have to use a number greater than or equal to 5. I already told you that whenever you see greater than or equal to, you have to go with the seal, right? Therefore, since the number is 5.5, it means that 5 bits are not enough. So what is the smallest number which is required to represent this? 6. So we need 6 bits in order to represent this -30. Even if you look at 6 bits, see, if you look at 5 bits, if you are looking at 5 bits, the number of the numbers that can be represented is -16 to +15, right? If you are looking at 6 bits, the number that can be represented is -32 to +31. Therefore, -30 can be represented using 6 bits. That is how we can solve it. So just try to understand this. One thing is you should be very thorough about the ranges. So this is not just useful here, in other subjects as well. In CO also we are going to use it. And second thing is we should be able to identify whether given number can be represented in the given size, given register or not. If it is not able, if you are not able to represent it there, then that is called as overflow condition. Don't worry, we shall see it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.